In today's video, we're exploring another super useful LangGraph design pattern called parallelization. This technique helps your agents do multiple things at the same time instead of one by one. We'll break it down with a clear visual graph example, and by the end, you'll know exactly how and when to apply parallelization in your own LangGraph workflows. So firstly, what is parallelization? It is all about doing multiple tasks at once, kind of like multitasking but structured and efficient. Let's say you're generating learning content for a topic. Normally you write the content, then generate quiz questions and then summarize it. This is a sequential flow which we discussed in the previous videos. But what if the content generation is done and you want to summarize and generate quizzes simultaneously? That is where parallelization shines. It lets your app branch into multiple tasks at the same time, speeding things up and reducing delays. You can think of it like operating a professional kitchen. The head chef starts with the recipe idea, let's say a pasta dish, but instead of doing everything by himself, he assigns the tasks to his team at the same time. One person chops the veggies, another boils the pasta, another stirs the sauce, all in parallel. The end result, the dish is ready much faster and the workflow is smooth because everyone handled their part at the same time. That is exactly what parallelization does in LangGraph. Let's understand this better with the diagram right here. We start at the start node and pass in a topic, for example F1 racing. The content generator node takes this topic and writes out detailed learning material. Now here's the interesting part. From this point on we split. One path goes to the quiz generator where we turn the content into quiz questions. The other path goes to the content summarizer where we shorten the material into key points. Both tasks run in parallel, and once they are done, the flow rejoins at the end node. Notice how this saves time because we don't wait for one to finish before starting the other. Now it's time to bring this graph to life, so let's fire up our VS Code. Alright, so I've already scaffolded a UV project inside my VS Code. Install dependencies include LangGraph, LangGraph CLI, LangChain, LangChain Grok, Grandalf, and Python.env. Make sure your .env file contains your Grok API key. If you're unsure, I've covered this in my previous videos on LangGraph. Now let's start coding the workflow just as you saw in the diagram. Alright, so firstly let's import our environment variable. So for that I'll say from .env import load_.env and call this function at the root of a Python script with override equal to true. Then we'll import our LLM. So for that I'll say from langchain_grok import chatgrok, and I can instantiate that into my LLM variable. We can pass in a model name, and let's set the temperature value to around 0.8. And now for the model's name, we'll be going with llama 4. Now let's start building our state graph. So for that, I'll import the pydantic space model. So from pydantic import base model along with the field, and I'll say class graph state takes in my base model, and we have a user's input, or we'll say topic for this video. Topic is a string, field and description is the topic for the graph. Let's call this the topic for the graph. And then we have our detailed report, right? Detailed report is a string. Description, a detailed report of the graph including nodes and edges. We'll just modify this a bit. A detailed report of the topic. We don't need all of this. And then we'll call this quiz_questions is a string with description set as quiz questions related to the topic. Finally, we have our summary, which is a string, and the description is summary of the topic. Now let's start building our nodes. Firstly, we have our content_generator, which takes in our graph state. Then we fetch the topic. So I say state.topic, and then we give a prompt to this. So let's import a prompt as well. And now I can say prompt equal to prompt template, and a template saying generate a detailed report on the topic. Input variables is our topic, and I can create a chain out of this. So again, we go to the prompt and then we call our LLM, and now I can say something like response equal to chain.invoke, and our topic is the topic itself. Now we can return this updated state of the graph, which is our detailed report from this node, right? Return response dot content, as it's a AI message. All right, now let's create our second node, which is the quiz generator. So let's modify this a bit. Quiz generator, we have the report state dot detailed report, generate 5 quiz questions on the following report, and then we pass in a report as the input variable, and then we return quiz questions from this node. So again, response.content. You can modify this prompt as you want, make it more dynamic or more improve its quality, to be exact. And now let's create a final node, which would be our summarizer or summary generator. So let's call this summary generator. And again, we have our topic first. Generate, or let's say summarize the given report. Okay, we have to pass in the report itself, not the topic. So detailed report, and yeah, it should be working as we saw in the diagram. And now let's build a graph. So for that, I'll say builder equal to state graph. So firstly, we have to import state graph and the starting and end nodes as well. So from langgraph.graph, we have got our state graph along with the start and end nodes, right? We have been doing this for a couple of times, so I think you guys have been accustomed to this syntax and all of the functions that we've been using. So now builder.add node. Our first node would be content generator, and then we have got our second node, should be quiz generator, summary generator. And now let's start building our edges also. So I'll say we start at the content generator, and now here comes the hero section of this video, that is to actually have this parallelization in the whole graph. So now what we want is, from the content generator, we have to go to both these nodes at the same time, right? So let's do that. So from this node, so from this edge, we can see that from this content generator, we are going to quiz generator, and at the same time we have to go to the summarizer as well, right? So let's copy this down, and we say summary generator, and now I can say my graph is builder.compile, and I can see this graph in the terminal. So let's call graph.get_graph dot draw ASCII, and let's run this python main.py. And as we discussed, we get the detailed report, we generate the quiz and the summary simultaneously, and then we end, right? So now let's give this an input. So I'll say response equal to graph dot invoke, and I have got my topic to be F1 racing, right? Now let's print this response as well. Let's see what we get back. Okay. Oh, all right. So I forgot to do one thing, that is to make these fields optional while invoking the graph. So let's do that as well. Also, we have to end the graph run if we get some output from the quiz generator and the summary generator. So we have to do that as well. Add edge, quiz generator, we go to the end node, summary generator, we go to the end node. And now let's make these fields optional. So for that, I have to import optional from typing, make their default value as none because you're working with Pydantic. All right, so in our summary generator, we have to update the summary of the state. So let's change that to summary. And now let's run this again. All right, guys, so we finally got our output. And we can see that we got our input as a fundraising detailed report is this. We've got a massive amount of content on F1 right here. And I'm just looking for our other nodes output as well. So let's do one thing. Let's see this output in LangGraph Studio as well. So we get some better visualization of the graph itself. So for that, we have to specify a langgraph.json file in the projects root directory. So we say langgraph.json, and then we pass in this code. Then we pass in this code from their documentation, and then we say langgraph dev to fire up the LangGraph Studio. Let's give it some time. You can see that a graph has been printed out in a very nice interface, and we can actually interact with this as we've been doing in our previous videos as well. So let's give it a topic of F1 racing and hit submit. You can see this node being highlighted, and for a very short amount of time you can see that these both nodes will be highlighted together. And yeah, that is what parallelization helps us to achieve. So from our content we get a detailed report on F1, introduction, history of F1, current F1 era, F1 racing season, key components of F1 cars, blah blah blah. We got quiz questions as well. I hope there are 5. So we got quiz questions along with their answers. So question 1, question 2, question 3, question 4, and question 5. And finally we got our summary. So all this happened in a parallel manner, and that is what we were trying to achieve in this video. That brings us to the end of this video. Grab the code and documentation from the links in the description. If this helped, give it a thumbs up and subscribe for more hands-on AI workflows with LangGraph. I'll see you in the next one. Until then, keep building smart.